Today we'll discuss CMI's 2015 paper, and the first question is 10 people sitting around a circular table decide to donate some money for charity. You're told that the amount donated by each person was the average of the money donated by the two persons sitting adjacent to him or her. One person donated rupees 500. Choose the correct option for each of the following two questions. Write your answer as a sequence of two letters A, B, C, D. Now the first question is, what is the total amount donated by 10 people? So we have 10 people sitting around a circular table, and one of these person has donated 500 rupees. Now we know that the amount donated by each person was the average of money donated by two persons sitting adjacent to him or her. It is only possible when money donated is in AP. So if it is 500, then the next one is 500 plus D. Next one will be 500 plus 2D. And finally, this one will be 500 plus 9D. Now, even for this person, 500 has to be the average of these two. So if we take the average of these two, then it will be 500 equals 1000 plus 10D by 2, that is the value of D is 0. And when the value of D is 0, that means it is a constant AP. So each person has donated 500 rupees exactly. So what is the total amount donated by 10 people? It will be 500 into 10, and that is exactly rupees 5000, option A. And the next question is, what is the maximum amount donated by an individual? Each person has donated 500 rupees. So it is exactly rupees 500. That's your option A. Now question number 2 is, consider all finite letter strings formed by using only two letters A and B. We consider the usual dictionary order on these strings. Now formal rule is, to compare two strings W1 and W2, read them from left to right. We say W1 is smaller than W2 if the first letter in which W1 and W2 differ is A in W1 and B in W2. Now for each of these three statements below, we have to find if they are true or false. Now the first one is, let W be an arbitrary string. There exists a unique string Y satisfying both the following properties. First is W is less than Y, and then there is no string X such that X lies between W and Y. So if you have any string, say W, then we can define this string Y as W, and then we'll add 1A to it. So if Y is W into A, then clearly Y is greater than W, and there cannot be any string X which lies between W and Y. So that means first one is true. Second one is, it is possible to give an infinite decreasing sequence of strings, that is a sequence W1, W2 such that Wi plus 1 is less than Wi for each positive integer I. Now there can be infinitely many possibilities. It could be B, it is greater than AB, AB is greater than AAB, it is greater than AAA and B. This way we can generate infinite decreasing sequence of strings. So that means this one is also true. Now third part is, fewer than 50 strings are smaller than ABB, ABA, BB. Now this is not true. We can have infinitely many strings formed from A, and all those strings, they'll be smaller than this given string. So if we choose these strings as A, AA, AANA, and so on, there'll be infinite such strings. That means the C is obviously false. So answer to this is true, true, and false. Now the third question is, a positive integer n is called a magic number if it has the following property. If A and B are two positive numbers that are not co-prime to n, then A plus B is also not co-prime to n. For example, 2 is a magic number because sum of any two even numbers is also even. Now we have to find which of the following are magic numbers. Now let us say n is of the form sum p to the power x and q to the power y, where p and q are prime numbers. Now if n and a, they are not prime, then we can choose sum a, which is p to the power x1 into sum n1 And we can choose this b to be q to the power y1 into n2. And in this case, a plus b, which is p to the power x1 n1 plus q to the power y1 n2. It may not be, it may be co-prime to n. So for this magic number, a plus b will not be co-prime to n if both a and b, they are factors of same number. That means this n, it must be of the form some p to the power x. So n has to be some power of prime number. So out of these 129, 128, 127 and 100, 128 is 2 to the power 7 and 127 is 3 to the power 5. So both these numbers, they are some powers of prime. So that means these two numbers, 128 and 127, they are magic numbers, whereas 129 and 100, they are not magic numbers. So answer to this question is n, y, y, n. Now the fourth question is, let a, b and c be unknown constants. Consider the function fx. Now we need to write the values of a, b and c such that f double dash x exists for all real x. Now for f double dash x to exist, the function should be continuous, and this function is continuous everywhere. We just have to check its continuity at 0. So if we write f0 negative is c, and f0 positive, it will be log 1 0. So if we compare it, we'll get the value of c as 0. And then its derivative should also be continuous. So if we find f dash x will be 2ax plus b when x is less than equal to 0, and here will be 1 upon 5x plus 1 into 5 when x is greater than 0. Now left hand derivative at 0, it is b, and right hand derivative at 0, it is 5. That means value of b, it must be 5. And for its second derivative, again left hand limit must be equal to its right hand limit. That means if we find f double dash x, which is 2a when x is less than equal to 0, and minus 25 upon 5x plus 1 square when x is greater than 0, f double dash 0 negative is 2a, and f double dash 0 positive is minus 25. If we compare it, we'll get the value of a as minus 25 by 2. So value of a is minus 25 by 2, b is 5, and c is 0. Now question number 5 is, consider the polynomial px, which is x plus a1 into x plus a2 up to x plus a10, where ai is a real number. Suppose that all the 11 coefficients of px are positive. If we multiply them, we can write x to the power 10 plus cyclic summation a1 into x to the power 9 plus cyclic summation a1 a2 x to the power 8, and finally it will be a1 a2 into a10. Now it says all the 11 coefficients, they are positive. If all the 11 coefficients are positive, that means all the ai's, they must be greater than 0. So the second one, it is true. And if we find roots of this equation are minus a1, minus a2 and minus a10. So if all the ai's are positive, then minus ai's are negative. So all the roots of this equation, they are negative. So this equation, it will have 10 negative roots. Now since it is a polynomial with even power, it will start from infinite and it will end at infinite. So when the polynomial starts at infinite and ends at infinite, it will have a global minimum at some point. That means this statement 1 is also true. So first is true and second is true. Now this third part is all real roots of p dash x must be negative. Now p dash x, it's a polynomial of degree 9. Now we need to know this polynomial has real roots or not. Now there are 10 roots of this equation, minus a1, minus a2, minus a3. Now from Rolle's theorem we can say that between two roots of fx there will be at least one root of f dash x. So between minus a1 minus a2 there will be one root. Between minus a2 and minus a3 there will be this one root. So in between 10 roots there will be 9 roots of p dash x. So all the roots of p dash x, they must be real. And since all the roots of this equation, they are negative, roots of p dash x, they'll also be negative. That means statement 3 is also true. So answer to this question is true, true, true and true. Now question number 6 is, let C1 be a circle with center minus 8, 0 and radius 6. So if we write this equation, it will be x plus 8 whole square plus y square and it will be 6 square. So this equation will be x square plus y square plus 16x plus 64 minus 36, which is 28 equals 0. And then we have this second circle C2 with center at 8, 0 and radius 2. So it will be x minus 8 square plus y square equals 2 square. So it will be x square plus y square minus 16x plus 64 minus 4 will be 60 equals 0. Now it says given a point P outside both the circles and let L1P be distance from C1 and L2P be distance from C2. Now it says L1P is 3 times L2P. Now we know that length of tangent is nothing but under root S1. So if this point is alpha comma beta, then L1P will be under root of alpha square plus beta square plus 16 alpha plus 28 and it will be equal to 3 times under root S1 for this will be alpha square plus beta square minus 16 alpha plus 60. Now we square it, we can write this as alpha square plus beta square plus 16 alpha plus 28 and it will be equal to 9 alpha square plus 9 beta square minus 16 into 9 alpha plus 540. Now this is 8 alpha square plus 8 beta square and then minus 160 alpha. Now 540 minus 28 is 512. So it will be 512 equals 0, which is alpha square plus beta square minus 20 alpha plus 8648 plus 64 equals 0. So locus of this point P, it will be this circle whose equation is x square plus y square minus 20x plus 64 equals 0. What is the center of this circle? Center of this circle is at 10, 0 and its radius will be under root of 100 minus 64, which is simply 6. So center at 10, 0 and radius equals 6 units. Now question number 7 is, by the binomial theorem, we can write root 2 plus 1 to the power 10. It is this summation I varies from 0 to 10 Ci into root 2 to the power I. And if we have to get it in this form, we have to write this as 1 plus root 2 to the power 10 and it will be equal to this summation I varies from 0 to 10 Ci into root 2 to the power I. Now it says we have to find the value of I for which this term is the largest term among all the 11 terms. So basically we have to find numerically greatest term. Now we have discussed this in one of the previous videos. If we have to find numerically greatest term for x plus a to the power n, we will find some alpha which is n plus 1 upon 1 plus mod x by a. So in this case, if we find this alpha, it'll be 10 plus 1 upon 1 plus, now x is 1 and a is root 2. So it'll be 11 root 2 upon root 2 plus 1, or we can write this as 11 root 2 into root 2 minus 1, which is nearly 6.44. And we know that if alpha is not an integer, then its numerically greatest term is given by t greatest near function of alpha plus 1, which is 7th term. And if the term is 7th one, if we write the expansion, it will be 10c6 into root 2 to the power 6. So in this case, value of I is going to be 6. Now we come to its second part. It says, for every natural number n, let root 2 plus 1 to the power n be pn plus root 2 qn, where pn and qn are integers. Then we need to find this limit n tends to infinite pn upon qn to the power 10. Now if we take this limit here, it will be infinite. So we won't get any result from this. What we'll do is, we know that if we take the expansion of root 2 plus 1 to the power n, it will be c0 root 2 to the power n plus c1 root 2 to the power n minus 1. And if we consider root 2 minus 1 to the power n, it will be c0 root 2 to the power n minus 1 to the power 0 minus c1 root 2 to the power of n minus 1. So the expansion of root 2 minus 1 to the power n will be nothing but pn minus root 2 qn. Now we take limits both sides. Now root 2 minus 1, it lies between 0 and 1. So a to the power n in that case, it will be simply 0. And here it will be limit n tends to infinite pn minus root 2 qn. We can also write this as limit n tends to infinite pn upon qn. It will be simply root 2, and then limit n tends to infinite pn upon qn to the power 10 will be root 2 to the power 10, which is simply 32. Question number 8 is, the format for car license plate in a small country is 2 digits followed by 3 vowels. That is 04 IOU. Now if the digit 0 and vowel O, they are both present on it, then we say the license plate is confusing. Now first question is, how many distinct number plates are possible in all? So we have 5 places. So for this first one we have 10 choices. For the second one also we have 10 choices. And then for vowels we have 5 choices each. So it will be 10 into 10 into 5 into 5 into 5, which is 12500. So altogether 12,500 different license plates are possible in this case. Now we'll consider 2 cases. Case 1, when 0 is not present, and case 2, when 0 is present in the number plate. Now if 0 is not present, then we have 9 choices here, 9 choices here, and for each of the vowels we'll have 5 cases. So it'll be 5 into 5 into 5, which is 81 into 125. And the second case when 0 is present. So if 0 is present, then vowels cannot take O. So here we'll have 4 choices each. So it'll be 4 into 4 into 4. And here it should have at least 1 0. So what we'll do is we'll take total cases, so which is 10 into 10. And from that we'll subtract all the cases where we do not have any 0. So there'll be minus 9 into 9 into 4 into 4 into 4, which is 100 minus 81 into 64, which is 19 into 64. Now we need to add them. So the total number of plates which are not confusing is 1 1 3 4 1, and that is the answer to this question. Now question number 9 is, we are given a function fx which is sine inverse of sine pi x. Now write the values of the following. Now what we'll do is we'll draw the graph of sine inverse of sine pi x, and for that we'll draw the graph of sine inverse of sine x. Now this is pi by 2 and this is minus pi by 2. This is pi, 2 pi, 2 pi and 3 pi. This is pi by 2, 3 pi by 2 and 5 pi by 2. Now this is the graph of sine inverse of sine x. If you have to draw the graph of sine inverse of sine pi x, we have already discussed it in transformation of graphs, that all we need to do is we just have to divide everything with pi. So here it will be 1 by 2, this one is 1, this is 3 by 2, this is 2, this is 5 by 2 and this is going to be 3. Now we need to find the value of f 2.7. Now 2.7, it will lie in this region, and in this region we have to find equation of this line. Equation of this line will be minus pi x, and then this graph, it is going to intersect at 3 pi. So when x lies between 2.5 and 3.5, in that case this fx, it is defined as 3 minus x into pi. Now we need to find the value of f 2.7. Now f 2.7 will be 3 minus 2.7 pi, which is 0.3 pi. You can also find the equation of this straight line using coordinate system. So this point is 5 by 2 comma pi by 2, and this point here is 3 comma 0. Now using 2-point form, we can find equation of this straight line. Answer to this first question is, this is 0.03 pi. Now we differentiate it, we'll write f dash x, and f dash x will be simply minus pi. So at 2.7, its derivative will be simply minus pi. Now we need to find value of this integral from 0 to 2.5 fx dx. Now from symmetry, these two integrals, they'll cancel out. The only integral value that we'll have is this triangular region, which is 1 by 2 into, now this is 1 by 2 and its height is pi by 2, so it'll be simply pi by 8. And fourth one is the smallest positive x at which derivative does not exist. So this function is not differentiable at this point. So the smallest value is at x equals 1 by 2. So here this one is going to be x equals 1 by 2. So answer to this question is 0.3 pi, minus pi, pi by 8 and 1 by 2. Now question number 10 is, suppose z1 and z2 are complex numbers. One of them is in the second quadrant and the other one is in the third quadrant. Then we need to find relationship between mod of z1 minus mod of z2 whole mod and mod of z1 plus z2. Now what we can do is we can write mod of z1 as mod of z1 plus z2 minus z2, and we know that this is always less than or equal to mod of z1 plus z2 plus mod of minus z2, and we take it on the left hand side, we can write mod of z1 minus mod of z2 is less than or equal to mod of z1 plus z2, or we can write mod of z1 minus z2 will be less than or equal to mod of z1 plus z2. Now we know that we'll get equality when both the complex number, they have the same argument. But in this case, one of the complex number is in second quadrant and the other one is in third quadrant. So we won't have this equality sign here. So in this case, it'll be the strict inequality, which is mod of z1 minus z2 will be strictly less than mod of z1 plus z2. So here the symbol will be strictly less than. Now second part is complex number z1, z2 in origin form an equilateral triangle, then we need to find relationship between mod of z1 square plus z2 square and mod of z1 z2. Now this we have already studied in geometry of complex numbers. So again, I'll provide the link to that video in the description below. We know that if vertices of an equilateral triangle are z1, z2 and z3, then z1 square plus z2 square plus z3 square, it is equal to z1 z2 plus z2 z3 plus z3 z1. Now in this case, z3 is origin. So if we put z3 as origin, we can write z1 square plus z2 square will be equal to z1 into z2, or if we take this mod sign, then we can write mod of z1 square plus z2 square will be equal to mod of z1 into z2. So here we'll have this equal to sign. Now for this third part, it is given that 1, z1, z2 and z7 are 8th root of unity. We need to find value of this product. Now this again is a standard question. This we have studied in nth root of unity. Again, I'll provide the link to that video in the description below. So we can write this equation as z to the power 8 minus 1 will be z minus 1, z minus z1, z minus z2 up to z minus z7. So we can write this as product I varies from 1 to 7, z minus zi will be equal to z to the power 8 minus 1 upon z minus 1. Now we'll take this limit z tends to 1. So if we take this limit z tends to 1, it'll be this product 1 minus zi, and this is standard limit, which is simply 8. So answer to this question will be simply 8. Now question number 11 is, there are 4 distinct balls labeled 1, 2, 3, 4 and 4 distinct bins labeled A, B, C, D. The balls are picked up in order and placed into one of the 4 bins at random, and let EI denote the event that first I balls go into distinct bins. Now calculate the following probabilities. Now first is, we have to find this probability that event is E4, and when the event is E4, that means all the 4 balls, they went into different bins. So first we have to find total number of cases. So we have 4 balls, and for each ball we have 4 choices. So total number of ways will be 4 into 4 into 4 into 4, 4 times. So it will be simply 4 to the power 4. And now if all the 4 balls, they go into different bins, then we just have to arrange these 4 balls in 4 places, and it can be done in simply factorial 4 ways. So this probability will be simply factorial 4 upon 4 to the power 4. Now second one is this conditional probability. We have to find probability of E4 when it is given that E3 has already occurred. So it will be probability of E4 intersection E3 upon probability of E3. Now what is E4 intersection E3? E4 intersection E3 is nothing but it is simply E4, and here will be simply E3. Now probability of E4 is factorial 4 upon 4 to the power 4, and probability of E3 is probability of the event that first 3 balls, they go into different bins. So first we have to select which bin. So it will be 4C3 and then factorial 3, and for the last ball we have 4 choices. So it will be 4 upon 4 to the power 4. So this 4 to the power 4 will cancel. Now this factorial 4 will cancel. So it will be simply 1 by 4. Now this third one is probability of E4 upon E2. Now it will be probability of E4 intersection E2 upon probability of E2, which again is probability of E4 upon probability of E2. Now this is factorial 4 upon 4 to the power 4, and probability of E2 is first 2 balls, they went into 2 different bins. So it will be 4C2 into factorial 2, and then for the remaining 2 balls it will be 4 square and then 4 to the power 4. Here this 4 to the power 4 will cancel. So we can write this as 4 into 3 into 2, and here will be 6 into 2 into 16. So this 6 will cancel, 2 will cancel, and this is simply 1 by 8. Probability of E4 upon E2 is 1 by 8. And then finally, this probability of E3 upon E4 will be probability of E3 intersection E4 upon probability of E4. Now probability of E3 intersection E4 is probability of E4 and LB upon probability of E4, which is 1. So this is a sure event. So the required probabilities are factorial 4 upon 4 to the power 4, 1 by 4, 1 by 8 and 1.